Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. I will continue my video for IGCSE 0620 past paper. In this video, I was talking about specimen paper 4 for 2023 version and onwards. So let's continue with the lesson. So we are already done with question number 1, 2 and 3. I'm continuing from question number 4. Question is, sulfuric acid has many uses. Sulfuric acid is a strong acid. Define the term acid. Now you have to define in terms of proton. Acids are proton donors. So you write proton donor. Number 2, define the term strong acid. Strong acid completely dissociate in aqueous solution. So you write acid that is completely dissociated in aqueous solution. That completely dissociate in aqueous solution. B. Dilute sulfuric acid is used to make salts known as sulfates. A method consisting of 3 steps is used to make zinc sulfate from zinc carbonate. Step 1. Add an excess of zinc carbonate to 20 cm cube of 0.4 mole per dm cube. Dilute sulfuric acid until the reaction is complete. Step 2. Filter the mixture. Step 3. Heat the filtrate until a saturated solution forms and then allow it to crystallize. Number 1 suggests 2 observations which show that the reaction is complete. Step 1. Now they are asking about 2 observations which shows that the reaction is complete. Now whenever metal carbonate reacts with acid, there will be gas produced known as carbon dioxide. So there must be fizzing. So you'll write no more fizzing. First observation, no more fizzing. Zinc carbonate exists in the solid state. So when the reaction is complete, no more solid dissolves. So you write ZnCO3 stops dissolving. Number 2, state why it is important to add an excess of zinc carbonate in step 1 so that it can use all the acid. Define the term saturated solution. Solution which cannot hold any more solute particles. So you have to mention the temperature also, because at higher temperature, saturated solution become super saturated. So you write solution that cannot hold more solute at the specified temperature. Number 4, name another zinc compound which can be used to make zinc sulfate from dilute sulfuric acid using this method. Zinc oxide or zinc hydroxide. Remember, zinc oxide acts as amphoteric oxide. Number 5, suggests why this method would not work to make barium sulfate from barium carbonate and dilute sulfuric acid, because barium sulfate is insoluble. So we need soluble salt. In a titration, a student added 25 centimeter cube of 0.2 mole per dm cube of aqueous sodium hydroxide to a conical flask. The student then added a few drops of methyl orange to the solution in the conical flask. Dilute sulfuric acid is then added from a burette to the conical flask. The volume of dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide was 20 centimeter cube. The reaction is shown by the equation. 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Number one, state the color of methyl orange in aqueous sodium hydroxide. Sodium hydroxide is alkali. So in alkali, methyl orange shows yellow color or gives yellow color. Number two, determine the concentration of the dilute sulfuric acid in gram decimeter cube per decimeter cube using the following steps. Calculate the number of moles of aqueous sodium hydroxide added to the conical flask. So we know the strength of sodium hydroxide, it's 0.2 mole per dm cube. 0.2 mole per dm cube, and the volume is 25 centimeter cube. So you write 1000 centimeter cube, because we know 1 dm cube is equal to 1000 centimeter cube. 1000 centimeter cube contains 0.2 moles. Therefore, 25 centimeter cube contains x moles. So x will be 0.2 multiplied by 25 divided by 1000. So the answer will be 0.005 moles of sodium hydroxide. Calculate the number of moles of dilute sulfuric acid added from the burette. Now you'll write the reaction equation here. Here's the equation. NaOH, 2NaOH plus H2SO4. We know the number of moles of sulfuric acid is 1 and sodium hydroxide is 2. So what you will do, you will calculate the number of moles of sulfuric acid. 0.005 moles of sodium hydroxide reacts with x moles of H2SO4. So x will be equal to 0.005 divided by 2. The answer will be 0.0025. 5 moles of sulfuric acid. Calculate the concentration of dilute sulfuric acid in mole per dm cube. Now these are the moles which are present in 20 centimeter cube of sulfuric acid, which are initially used in this reaction. See, 20 centimeter cube of sulfuric acid is sulfuric acid. This is the volume for sulfuric acid. So you write 20 centimeter cube contains 0.0025 moles. Therefore, 1000 centimeter cube contains x moles. So it will be x is equal to 0.0025 multiplied by 1000 and divided by 20. So the answer will be 0.125 mole per dm cube. Now you got the moles of sulfuric acid. They are asking that you to calculate the concentration of dilute sulfuric acid in gram per decimeter cube. Simply you will convert moles into grams. Moles into grams. You know the formula? Mass is equal to number of moles multiplied by MR. Now we have sulfuric acid. The MR of sulfuric acid will be 98. So you'll multiply this by 0.125. Answer will be 12.25 grams per decimeter cube. This will be your final answer. Number 5, student investigates the progress of the reaction between dilute hydrochloric acid, HCl, and an excess of large pieces of marble, CaCO3, using the apparatus shown in figure 5.1. This is the figure. You can see dilute hydrochloric acid. You have an excess of large pieces of marble. This is gas syringe. A graph of the volume of gas produced against time is shown in figure 5.2. This is a graph. On x-axis, you have time. On y-axis, volume of gas produced, which is in centimeter cube. Number 1, state how the shape of the graph shows the rate of reaction decreases as the reaction progresses. You see the gradient decreases. This is a gradient. This decreases. So you write gradient decreases. Suggest why the rate of reaction decreases as the reaction progresses. It's very simple. Concentration of HCl is decreasing. Concentration of HCl is decreasing. Because if you look at the question, CaCO3, which is marble, it is in excess. So HCl is the limiting. It's just limiting here. So the gas produced will be depending on the limiting reactant here. So that's why concentration of HCl is decreasing. Number 3, deduce the time at which the reaction finishes. You look at the time by looking at the graph. Find the time. It will be 200 seconds. 200 seconds. The experiment is repeated using the same mass of smaller pieces of marble. All other conditions are kept the same. Draw a line on the grid in figure 5.2 to show the progress of the reaction using the smaller pieces of marble. Now they are just saying they have used smaller pieces of marble instead of large piece. So what will happen to the graph? The reaction will be acting fast here. So you will have new line which will be steeper than the printed line. And it means that it levels before 200 seconds. And starting point will be same. It will be like this. C, the original experiment is repeated at a higher temperature. All other conditions are kept the same. The resulting increase in rate of reaction can be explained in terms of activation energy and collisions between particles. Define the term activation energy. It's the minimum energy required to activate the reacting particles. So you can write minimum energy, minimum amount of energy that colliding particles must have. Number 3, explain why the rate of a reaction increases when temperature increases in terms of activation energy and collisions between particles. They are saying that the rate of reaction increases when temperature increases. What is happening? The particles having more energy. So they will start moving faster. There will be more frequent collisions. So the particles have energy greater than the activation energy. So this is 3 marks question. So first of all, you will write particles have more energy. Particles have more energy. And So move faster. So next one, more frequent collisions. More frequent collisions. It's very important. You have to write between particles. So because the collision can be with the walls of the container. So that you can say particles have energy greater than the activation energy. Particles have energy greater than the EA or activation energy. Number 6, alkynes and alkenes are homologous series of unsaturated hydrocarbons. All alkynes contain a C triple C or triple bond. A. Complete table 6.1 showing information about the first 3 alkynes. Table 6.1, the formula, structure and names given. First one is ethyne. This is ethyne. They are asking about the name for the second member. The third member is butyne. Recall the names for alkanes. If you know the value of N, 1, 2, 3, 4. We have methane. So you'll write meth. Ethane, so you have eth. Propanes, you have prop. Fourth one, bute. They have already mentioned eth and prop bute. So you have prop. So the name is ending on ine. Name ending on ine. So the name will be easy. Propine. Propine. P. Compounds in the same homologous series have the same general formula. Give 2 other characteristics of members of homologous series. You can write any of these. Contain same functional group. Differ one member. Each member by CH2 unit, or there is a trend in physical properties, similar chemical properties, same method of preparation. So contain same functional group, trend in physical properties, same chemical properties, same method of preparation, or successive member differs by CH2 group or 14 units. Number 2, deduce the general formula of alkynes. Use the information from table 6.1 to help you. Now they are asking you to deduce a general formula for alkynes. Let's write the molecular formula for each member. So we have ethyne, propine, bute, 1, ine. Look at the formula, it's C2H2. Next member, C3H4. Here's the formula. The third member, it's C4H6. Now, in each step, we know the general formula for alkane, which is CnH2n plus 2. This is alkane. And alkene, it's CnH2n. But you see, they are decreasing the each molecule. They're decreasing. There's decrease of two hydrogen atoms. So you can add for alkyne, it must be CnH2n minus 2. You can apply it, you'll get the formula, these formulas. So you'll write CnH2n minus 2. Alkynes are unsaturated. Describe a test for unsaturation. You have only one test for unsaturated organic molecules. Bromine, water, aqueous bromine. Bromine, water. We can write aqueous bromine, decolorize. Simply decolorizes. Number C, ethene and butene are alkenes. Draw the displayed formula of butene. They're asking about you to draw the displayed formula for butene. You know the formula for butene. If you know the value of N, it should be 4. It's alkene. So you know the general formula CnH2n. Putting these values, you will get C4H8. So there must be 4 carbon atoms. 1, 2, 3, 4. It's an unsaturated. There must be 1 carbon-carbon double bond. So I'm placing double bond between these 2 carbon atoms. Well, let's place hydrogen atoms. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this will be your final general displayed formula for butene. Number 2, draw a dot and cross diagram to show a molecule of ethene, CH2. Show outer shell electrons only. So I'm using the dot and cross here. So you have C here, H here. For C, I'm using dot. Hydrogen, I'm using cross. Should be like this. 2C and 4H. Now showing the electrons between each atom. Between 2 carbon atoms, there must be 2 pairs of 4 electrons. 1, 2, 3, 4. For this carbon, 1, 2. For this one, 1, 2. So all the 4 electrons for each carbon atoms are placed. Now let's place the valence electrons for each hydrogen atom. 1 for this one, 1 for this one, 1 for this one, and 1 for this one. So this will be the final dot and cross diagram for alkene. Ethene can be converted to ethanoic acid by 2-stage processes. In stage 1, ethene is converted to ethanol by catalytic addition. This is C2H4 plus H2O. You are getting C2H5OH. You are getting only one product. Number 1, suggest why stage 1 is called an addition reaction. Simple answer, one product form. Number 2, a catalyst is used in stage 1. Stage 1, other conditions that must be used here. So there are some conditions for this one. You can quote pressure or temperature. And steam is also used here. So you can write any of these. Anyone? Steam or temperature. 100 degrees centigrade, above 100 degrees centigrade, or pressure, quote pressure 20 to 100 atm. State what must be reacted with ethanol to form ethanoic acid. It's an oxidation reaction, so you have oxidizing agent, acidified aqueous potassium magnate. Acidified aqueous potassium manganate. Seven. This is the last question. 7. Carboxylic acids can be converted into esters. A, propanoic acid and methanol react to form an ester that has the molecular formula C4H8O2. Name this ester and draw the displayed formula. Name of the ester, displayed formula. How you're going to name the ester? Remember, whenever alcohol reacts with carboxylic acid, ester is formed. Alkyl group is coming from alcohol. We get alkyl group. In this case, you are getting methyl and carboxylic acid. You will get alkanoate. So propanoic acid, you will get propanoate. Name of ester will be methyl propanoate. Displayed formula. Now it's up to you if you want to start with methyl, you can start in this way. Now propanoate will be starting from this side. So you'll start with O. We have C, double bond O. 1, 2, 3. This is propanoate. Now I'm placing hydrogen atoms. This is methyl propanoate. Alternatively, you can draw this in this way also. 1, 2, 3. O, C, H3. Number 2, name another ester with the molecular formula C4H8O2. You can have any ester with this molecular formula. For example, in this case, you can have propyl methanoate. Remember, the total carbon atom should be 4. So you can have ethyl ethanoate. Number B, polyesters are polymers made from dicarboxylic acids. Name the other type of organic compound used in the formation of polyesters. Diol. Number 2, name the type of polymerization used in the manufacturing of polyesters. Simply condensation. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.